Hey everybody, so I hope you guys have a wonderful Friday, and let's go ahead and go through our notes today. So this beginning part, these few examples, are going back through that SLAP method that we did together before I left, so let's go through it. First couple. The ice cream shop offers a choice of 3 cone sizes, 15 flavors, and 8 toppings. So how many cones are possible if you can only choose 1 flavor and 1 topping? So we have 3 slots. 1 is for cone size, 1 is for flavor, and 1 is for topping. So there are 3 cone sizes, 15 flavors, and 8 toppings. And remember, when it comes to SLAP method, we are picking a cone and a flavor and a topping. So all of these would be multiplied together. And if we go ahead and we multiply, we would get out an answer of 360. So there are 360 different ice creams that can be made with those options. Question number 2, we want 3 letters followed by 4 digits. We did this one yesterday in class. There are 26 different letters, and on all license plates, we can repeat unless it tells us otherwise. And there are 10 different digits to be picked from. So this answer would come out right there, 175,760,000. So this next question tends to trip kids up on occasion. It says Nick's science test has a section with 12 true or false questions. How many different ways can Nick answer these questions? Well, the slots that we would be creating would be question 1, question 2, question 3, question 4, 5, 6, 7, 8, 9, 10, 11, and 12. And being as how they are true-false questions, each question has 2 different answer choices. It's true or it's false. So if I'm doing this problem and all of these slots are filled with 2s, we can say that this is 2 to the 12th power, and that's going to come out as 4,096. To enter her home, the Clayton family enters a 4-digit code. So we've got 4 slots. We know that in order for it to be a true 4-digit code, the leading number would be 0, or cannot be 0, excuse me. To be a 4-digit number, I should say, to be a 4-digit number, you cannot have a leading number of 0. But to be a 4-digit code, you can go ahead and lead with 0. Potentially, your code could be 0, 1, 2, 3. So from there, if we needed to do some multiplication of this, we would have 10,000. When it came to factorial, we have n factorial. So what n factorial is, as I showed you guys before, if we were doing 9 factorial, we'd have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all the way down. Remember, to get that factorial, you're going to hit your math button, scroll over to probability, and it is option number 4. By definition, 0 factorial is 1. Then there's something new. There's something called a permutation. A permutation, sometimes we see it in the format of big P, and it's n comma r. We potentially may see it as n big P r. Either one of those options. But what a permutation is, it's an arrangement or lineup of objects in which big key concept right here, so I'm going to highlight it, is that order matters. There are different things that we can talk about when order matters. I will tell you that if you ever have a position, such as there's a president, a vice president, a treasurer, or a secretary, that order matters. If you're running a race, whether you place in first place, second place, or third place, your order that you cross that finish line matters. Actually, your locker combinations are actually permutations. The order in which you enter those numbers in your locker combination matters. So as we look through this, I want you to understand when over here on the left-hand side, when I do this permutation and I see this N and this R, N represents the total number of objects available. So it's the number that you have to choose from, where R is the number that you are choosing. Okay, so N is the number that you have to choose from, and R is the number that you are choosing. All right, so something I would like you guys to see, that if you are doing a permutation and you see that this left number N is the exact same number as you see on the right, such as a permutation of 3 choosing 3, this outcome will always end up being whatever that number is factorial. So example 3, you have 3 objects, you are choosing all 3 of them. This would come out to be 3 factorial, which by definition is 3 times 2 times 1, so it would end up being 6. If you ever have to do this by hand, you would have this formula for a permutation. It would end up being your n factorial in the numerator divided by n minus r factorial on the bottom. Again, keeping in mind, n is the number of objects that you have available. It's the total number, and r is how many you are picking, how many you are choosing. So question number 5, as far as the letters in the word dinosaur, there are 1, 2, 3, 4, 5, 6, 7, 8 letters. We are choosing arranging the letters, which means that the order matters. So what we are saying is we would be doing all 8 letters, and then we would eventually have all 8 letters that we are choosing. So it would be a permutation 8 choosing 8. So what we've got down here and why this comes out, just this shortcut that I have right above here, this is supposed to be 8 factorial. If we substitute my n into the equation, this permutation equation, it's 8 factorial over 8 minus 8 factorial. This comes out to be 8 factorial over 0 factorial. And if you recall, 0 factorial is always 1. So it works out. If I do this 8 factorial, it ends up being 40,320. There are 40,320 different words or different arrangements of letters that I could get from the words or the letters in the word dinosaur. Okay, question 6, it says 7 students are competing in a geography bee. How many ways can they finish in first, second, and third place? So for this permutation, order matters. I have 7 students to pick from, and I am choosing 3 spots, first, second, third. By hand, this would be 7 factorial over 7 minus 3 factorial. But I'm going to go ahead and I'm going to pull up my calculator just so you guys can see what this would look like in our calculator and how to do it. If you hit your math button and you scroll over to probability like you did with factorial, you're going to see that option number 2 says NPR and option number 3 says NCR. We are going to do a permutation. Now I have a newer operating system, so it allows me to fill in these blanks. My 7 is my N and my 3 is my R. If you have an older operating system, you may have to hit 7 first, then hit your math button, scroll over to probability, choose option number 2, and then put your 3 afterwards. You don't have those boxes. Those boxes will say N and R in them. So it's kind of like you're telling your calculator to match them. 7 is being matched with your N, 3 is being matched with your R. I do have those fill in the blanks. So again, I have to hit my math button first, scroll into probability, option number 2, 7, choosing 3. And that's where I get that 210 from. You do always have the fallback to use the formula. As I go through question number 7, it says Melanie is taking 4 classes this semester: history, algebra 2, English, and chemistry. How many ways can these 4 classes be arranged in her schedule? Well, order matters. You guys know that what you take period 1, period 2, 3, and 4 are different than if you flip-flopped your schedule around. So of all 1, 2, 3, 4 of those classes, she is going to take all 4 of those. And going back to that little trick, this would end up being 4 factorial, which is going to come out as 24. Number 8, it says there are 16 players on a basketball team. How many ways can the coach, baseball team, how many ways can the coach make a batting order? Batting order in baseball matters. So this is a permutation. Of the 16 players, you are choosing 9 of them. So I put in mine, I go to my probability first. It's option number 2. 16 is how many I have to choose from, and 9 is how many I am choosing. So this is a pretty big number. It's huge. I don't know that answer, so I might actually have to go back to the equation on this one. 16 factorial over 16 minus 9 factorial, which is 16 factorial divided by 7 factorial. And if you guys recall from yesterday when we talked about factorial, this is 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, all the way down to 1, divided by 7 times 6 times 5, all the way down to 1. All of that's going to cancel out. If you can read scientific notation, which you should, we could say that this is 4.15 times 10 to the 9th. Okay, that E that you see in the calculator, that is scientific notation. That part is your E. That's implying scientific notation. Number 9, it says there are 28 students in Mr. Miller's homeroom. How many ways can the students select a student council representative and an alternate? So there are 2 positions. Positions are permutations. If there are 28 students and I want to choose 2 of them, I would hit my math, scroll over to probability, option 2. There are 28 kids. I'm choosing 2. There are 756 different options for us to choose a student council representative and an alternate. Now, 10 and 11 are done slightly different. And what I want you guys to see is that there are some repeated letters in the word automobile. Okay? The letter O is repeated. There are no other letters, though, that are repeated. Anytime that you have repeated letters, because in a word we cannot differentiate if you put this O first or that O first, it still looks the same. So we have to divide out by what we would call repeats. In your numerator, it's going to be your 10 factorial, but in your denominator, you're going to divide by the repeated letters. O was repeated 2 times. So I would divide out by 2 factorial. This is representing that O was repeated 2 times. So I would have 10 factorial divided by 2 factorial. 2 times 1 is 2, so I'm just going to leave it as a 2. So that means I would have 1,814,400. 1,814,400 different letter arrangements. Now, if we do something with disappear, there are 2 P's, there are 2 A's, so I have to divide out by both of those. There are 9 letters in the word disappear, it told me that, so my numerator would be 9 factorial, but there were 2 P's, so I'm going to divide out by 2 factorial for the arrangements of the 2 P's, and there are also 2 A's. So I have to divide out by 2 factorial representing my 2 A's. Now what I want you to be careful is those factorials, they cannot be combined. That is not the same thing as 4 factorial, so you do have to do them independently. So I would have 9 factorial on my top, and I would divide that by 2 factorial times 2 factorial. Close my parentheses. Make sure both of those are in my denominator to get 90,720. You're dividing out by the repeated letters and how many times it repeats. So then we have something else called a combination. A combination is a group. It's a committee. It's cards. Anytime you're doing anything with playing cards, it's just truly a group. Order does not matter. In a combination, this would be combination N comma R, or even NCR. That's what our calculator shows. N is still the total number of objects that you have to choose from. R is the total number of objects that you are choosing. And what happens with a combination, just as an example, in a combination, the numbers 1, 2, 3 is the same thing as 1, 3, and 2. The order does not matter. You're still using those same 3 numbers. So this, if order mattered, would be a permutation, but because order matters, this means the same thing because it's the same group of cards or of numbers in your hand. So this is when order does not matter. The definition of combination is n factorial over n minus r factorial, but there's an extra r factorial down there to make sure that we divide out by any of those groupings that use the same numbers just in a different order, because the order does not matter. If you see that you are doing a combination and it is n and n, you have 3 objects, you're picking all 3. This is going to be equal to 1. So a combination of 3 choosing 3, or even 3C3, both of those are going to come out to be 1. If you only have 3 objects and the order that you pick them does not matter, there's only one way to pick all 3 of those objects. So let's go through a couple examples. Number 12, it says Natalie has 16 close friends. She's choosing 5 to be bridesmaids. The order that she picks them doesn't matter. All 5 of those are going to be standing up in her wedding. So this would be a combination. She has 16 to choose from. She is choosing 5 of them. If we're doing the definition, this would be 16 factorial over 16 minus 5 factorial with an additional 5 factorial in that bottom. In our calculator, those of you with an older operating system, you have to hit 16, then hit your math button, then scroll over to probability and pick option number 3, NCR. If you have a newer operating system, you're going to click 16 or fill in those blanks with 16 and 5, and it does all that work for you. 4,368. Question 13, there are 24 students in Kyle's kindergarten class. How many ways can he choose? 8. The order doesn't matter because at the end of the day, all 8 of those kids are going to be at his party. So 24 kids in his class, he is choosing 8. So I'm going to go let my calculator do this work for me. 24 kids, I'm choosing 8. This is 735,471. Abby's adopting kittens. There are 18 kittens. She is picking 2 of them. Choosing 2. There are 153 different combinations of kittens that she can come home with. And I'm going to set up these next couple. You guys can push the buttons in your calculator. There are 12 employees at the sub shop. We want 4 for the Sunday evening shift. For number 16, there are 85 players on the football team. The coach wants to choose 3 for that group. Okay, we know it's a combination. They're going to say a committee or a group or cards. If you don't see a specific position, then you're going to go ahead and know that it is a combination. Combination, the order does not matter. Permutation, the order does matter.